Hello and welcome to another episode of How Computer Works. In this video, we will learning about memory, which is how computer memorizes data. Memorizes means it just keeps the data temporarily, and if it is turned off, it will again forget everything. So memory is just used for temporary memorization of data, and this memory is also known as, you can also say, RAM. No, it's actually not RAM, but it's just something that computer remembers for its own use, and mostly it is used for fast applications such as the applications you're already running in your computer in the background, or just needing for your application. And before I proceed to any further, you should really understand the previous videos much better. I mean, you should learn what are the output of different gates, and how are diagrams read in computer logic gates, or and learn everything from the previous videos, so that you can actually use those ideas to you're seeing a very complicated diagram here. You can use those ideas to actually relate to how this thing work, and this actually is what we can call memory, and it is how bits are actually remembered by computers. So I again tell you that you should really learn the previous videos and know how to read each different logic gates and their outputs, because in this video we'll be actually using all of them and some new concepts also. So please get to know your how logic gate are read. So here is a table I have drawn to keep things simple and so that you can follow on. And first, let me just explain what is this IS and those letters. I is the inputted bit we have just inputted, and this is the mostly the in bit which we want to remember, and O is the outputted bit that we have remembered. This is what will the O is the remembered bit actually, and this S is the setter. So if this is actually what tells the memory if it wants to remember, or if it will just ignore the input. So let me complete this table one by one, and I'll actually be going through each of them. And this E, A, B, C are just the follow along bit along these wires, and here is a zigzag where you can see the light blue color. I'll be explaining it as I go. So let me first tell about the input is off. Oh, let me use the zeros and ones so it will be a little easier. The input is off, but the setter is on, which means that it wants to remember the I, which is 0, and make the O also 0. So let me show you how it works. As S is 1, it will go through this wire, and as I is 0, this output, this part will be off. I mean, this part will be on, and so this E will be on, and here there is an intersection between two wires, and this will go to E as well as A. And because from S, the one goes through this wire and also through this NAND gate, and also E is also getting through this NAND gate, so this B will become off. Let me, as both E and S are on, let me just write this down. E is 1, those A is also 1, and as B, both S and E is on, this NAND gate will produce B as off. And now here's the tricky part. In gate 4, you can see that from B it is receiving the 0, but it is also receiving the another input from this gate 3. And C was if this B is 0, then C will be 0 anyway because it's a NAND gate, so it will produce a 0 if any one of the inputs are, oh no, it will produce C as 1 as if any of the inputs are B or off. So as B is off, C will be on, C will be 1. And from the C becomes C1, it travels through the zigzag wire and goes to logic gate 3, then gate 3, and from A, as A was 1 and C is also giving 1, this part 3 will be off, and as well, so O is also now off. And from that again it travels back to the zigzag wire, and as one of the input is again 1, C will still be 1. So the big thing to take in from here is if the setter S is 1, then I will be whatever, I mean O will be whatever I was. So I is 0 now. I mean O is 0 now because I was 0. I is 0 and the setter 1 is on. Now we'll be looking at another combination, and that is if I is now on and S is 1, which means that O should be 1 because it wants to remember the input I. So let me again draw the diagram as I go and write the ones and zeros for each. And if as S and I are both on, you will definitely be off because it's a NAND gate. Then A will also be off because it takes the input from this intersection, which is both E and A, so that will also be 0. And as E is 0 and as this is an AND gate, B will be 1 and B will be 1 because one of their inputs are 1, so B will become on. And now again we come to C, and first let me tell you from this because this is actually more complicated. We have to look at from different angles. So if A is now off, so this logic gate 3 will produce on whatever the other output is, so it will produce 1, and from that it will go down to logic gate 4, and as this is 1 and B is also 1, so C will now be C will now be 0. What is hap sorry, got a bug here. Okay, C will be now 0. And from that again, oh, and also O will now be on because A was 0, so O will be 1, the output is 1. And again C will be off because from this on came the 1 came, and as B was 1, C will again still be 0. So the big thing to take in from this is if S is 1, S is on, which means the setter is on, which means that the memory wants to remember input I is 1, and so O will still be same as 1 as long as S is 1. So if O is 1, that means O remembered I, which was 1. Sorry for all the zeros and ones, but you again let me say what the big idea is, that if S is 1, the O will be whatever I is. So now another combination is if S is off, and let me first say if I was 1, will it still remember O? It shouldn't, because as setter is off, memory shouldn't be able to remember any more input, so it will be the previous O value. So let me just say what if O is, let me actually go through this diagram and then I'll explain. If S is 0, then E, B and A will be on no matter what. So these three will be on if S is 0, no matter what, because from here if any of the input from NAND gates are 0, then it will produce a 1. So this EAB will be 1, no, whatever I is. So if O was previously 1, which means O was, not is, O was previously on. So now let's proceed. C is going to be, as B is 1 and A is 1, 3, the logic gate 3 will produce on 2 because A is on, and so from that it will go through this wire and again to logic gate 4, and so C will be produced as 0, 0, 0, and A, as A was 1, it will also produce 0. Output O as still on, so it didn't change. If it was previously 1, it will still be 1, and again C will become off because both input from logic gate 3 and logic gate 4 are 1, so it will again, it will keep remaining 0. And the last combination is if S is 0 and I 0, and will it still remember O? It should. And now we'll take 0 as it was off or whatever, because if setter is 0, it will be whatever O was. O will keep becoming what, keep be what it was. Sorry for all the confusion because I have to repeatedly say everything. So if S is 0, E, A and B will be 1, nor whatever I is. And so C will now be, as O was 0, C will now become 1 as well, because any input from logic NAND it will produce a 1, so C will now be 1. And as C is 1 and A is 1, C output O will still, it will again be 0 and it will keep being 0 and it will not be changed. And now again C will become 1 because one of their input is 1 and B is 1, and as output O is off, C will now again be off. From output logic gate output 3 produces a 0, so O is 0, and from there travels to logic gate 4 and again makes C off. So that is how memory works, and that is all there is to it. This is actually how a memory works in terms of logic gate, and now I'll be drawing a simplified diagram, so we don't have to draw this complex diagram all over again. Let me erase this to drag. Okay, let me not erase this part. I'll just draw a simplified diagram. Memory, we'll be calling this M or memory. Here are the input, not actually input. I is the input and S is the setter and O is the output. This is the simplified version of this whole RAM. So that's it, and that is how computer actually memorizes bits. If you want to if you want to memorize anything, and that is how memory works. If you like this video, please subscribe to our channel, and if you want any more videos, please post in the comment, and if you have any queries still, you can ask in the comments. Sorry for this long video, but this was very complex, so it had to be long. To learn more, please read this book, But How Do It Know, written by Clark Scott. this is the same book I've been using to explain the computer terms, and in this book you will find all the subject in more details. To learn more you can watch click on the link in the description or just visit buthowdoitknow.com.